Hello, everyone. Now I will introduce the usage of the HUCEEN AR04 module. The AR04 module is a temperature measurement module. The module has a resolution of 16 bits. It supports the connection of 4 channels of RTD thermal resistance signals. This module is connected to an RTD thermal resistance sensor. When used for temperature measurement, the input resolution of the module is 0.1 degrees Celsius or 0.1 degrees Fahrenheit. That is, if the value collected by the module channel is 230. It indicates that the current temperature is 23.0 degrees Celsius. The AR04 module can accommodate the connection of 4 channels of RTD thermal resistance signals. Each signal path includes 4 connection terminals: M-positive terminal, M-negative terminal, I-positive terminal, and I-negative terminal. It can support the connection of 2-limit RTD, 3-limit RTD, and 4-limit RTD signals. Take the 3-limit RTD connection channel 0 as an example. After shorting the M-positive terminal and I-positive terminal, connect one wire. Then, connect the I-negative terminal and M-negative terminal to 2 separate wires respectively. Take the AR04 module channel 0 as an example. A PT100 thermal resistance sensor is connected on this channel. This thermal resistance sensor is used to measure the actual temperature. Add an AR04 thermal resistance module to slot 0 of the CPU's system block. Click on the AR04 module and complete the parameter configuration for module usage. First, configure power anomaly alarm. Check the user power option. If the power supply of the module is abnormal, after checking the user power option, the DIGA indicator light on the module will flash red. Second, configure channel 0. Click channel 0. In the type option, select thermal resistance 3-wire. If using a 4-wire RTD thermal resistance, then select thermal resistance 4-wire. Select the type of the thermal resistance at resistor. If using a PT100 thermal resistance, then select PT100 here. Select the coefficient of the thermal resistance at the coefficient option. Choose the coefficient provided by the thermal resistance used. In the scale option, you can select Celsius or Fahrenheit. Here, the default Celsius is selected without modification. Other parameters can be set according to the default. When the RTD thermal resistance sensor is used for temperature measurement with an input resolution of 0.1 degrees Celsius or 0.1 degrees Fahrenheit, only the collected digital quantity needs to be multiplied by 0.1 to obtain the actual temperature value. However, due to the difference in data types, the value of the analog input channel is an integer. So the value of the analog input channel needs to be converted to a double integer first, and then converted to a real number before multiplying by 0.1. Converting the integer to a double integer can be achieved using the I_DI instruction. Fill in the input pin as AIW16. The output can be stored using the accumulator address AC0. Then convert AC0 through the DI_R instruction to a real number and store it in the accumulator AC0. Finally, multiply the value of AC0 by 0.1 through the MUL_R instruction, and the result is placed in VD0. So VD0 is the actual temperature value. By the program in the monitoring software, the current temperature value is seen as 25.9 degrees Celsius. When heating the thermal resistance probe, At this time, the current temperature value collected can be seen to be rising. Note: during the use of the AR04 module, for some unused channels, a short-circuiting method needs to be adopted. This is to prevent any interference with the normal operation of other channels of the module. The short-circuit method only requires shorting the positive and negative ends of the I channel together. The above is the usage introduction of the HUCEEN AR04 temperature measurement module. Thank you all for watching.